Now in this lesson I'm going to introduce you to a topic called calculus. Now this is not ideally the first lesson of calculus, but it's probably a good place to start in the situation we're in. So calculus makes use of something called dy by dx, which is a process called differentiation. Now basically you start off with an expression y equals. I'll take an easy one, y equals x cubed, and in order to establish dy by dx there is a rule that applies. Now there is a proof behind this, and arguably that should have been my first lesson, but it's fine to start here because at the end of the day you've got to learn the rules. The rule for finding dy by dx, i.e. differentiating that, is as follows. You bring the power down and you take one off the power. So the differentiation of x cubed would be 3x squared. Do another one. Y equals 4x squared. So in order to work out dy by dx, then you would bring down the power, so 2, but there's already a 4 there, so that's 8. 4 times 2 is 8. X, take 1 off the power. Well, if I take 1 off that power, I get power 1, which we don't bother writing. So 8x is your answer there. The third one, y equals 9x. Then to work out dy by dx, apply the same rule. Well, the power is a 1 there, so I'll bring the power down. That gives me 9, because 9 times 1 is 9. Take 1 off the power means that the power is now 0. And one thing you should have learnt at high school is that any quantity to the power of nothing is 1. So if that's 1, 1 times 9, the answer is 9. So these are the rules for differentiation. If you're given a quantity of x to a power, you bring the power down and you take 1 off the power. If you've got a number of, a being a constant, if you've got a number of those, then you need to make sure that you times the power by that number at the front. If I had a number of x's, i.e. in the last example 9x, then you end up with just the differentiation being the 9, or a in this case. However, if you have a numerical quantity, then the differentiation of a numerical quantity is nothing. There is proof for that, but that's for another day. So here are a few examples, 2 of which we've already looked at. In the first instance, dy by dx, i.e. the differentiation, is 3x squared. In the second case, the differentiation is equal to 8x. Now in the third and fourth case, when you've got a number of situations on here, you take each one separately. So the differentiation of 5 is nothing. The differentiation of 3x is 3. So the differentiation of that one is minus 3. In the case of the last one, the differentiation of 3x squared is 6x. Differentiation of 5x is 5. And differentiation of 1 is nothing. Now, what we are actually finding when we do differentiation is we are finding the gradient of any particular point on that curve. So on that curve, if I was to put x equal to 1, the gradient would be 3 of the tangent that would be drawn at x equals 1. So you can establish the gradient at any point on that curve. Likewise on that curve. Now we know that that is a straight line. We know from y equals mx plus c that the gradient was equal to minus 3 anyway. The calculus has shown us that as well. And likewise, if I wanted to work out the gradient at any particular point on that curve, say for example x equals 2, all I would have to do is replace that letter with a 2 and I could see what the gradient was equal to. Okay, so putting this into practice, we've got a curve, a cubic, and we're told to find the gradient when x equals 1. So the gradient for a curve, we need dy by dx. Well, as I've already pointed out twice, the differentiation of x cubed is 3x squared. Take, differentiation of x squared is 2x, and differentiation of 1 is nothing. When x equals 1, the gradient, like dy by dx, will equal 3, because 1 squared is 1, times 3 is 3. Take 2, because 2 times 1 is 2, so the gradient is 1. So this one's similar to the previous, but a bit more challenging and using quite a few skills from your GCSE days. Again, we've got a curve and we're asked for the gradient. So we need dy by dx. So differentiation of that is 6x squared, plus sign, so plus sign. Differentiation of that is 2x, differentiation of that is nothing. However, this time, we're not told the x-coordinate. In fact, we have to work out the x-coordinate. We want to know when is the gradient 0. So we want to know when is that equal to 0, which means we have to factorise. So take a 2 and an x outside of a bracket. And we can see that this is true when x equals nothing, but it's also true when x equals not minus 1, but minus 1 over 3. Now, if I was to put that back into the original, so when x equals 0, we can see that the y-coordinate works out to be 2. And when x equals minus 1/3, the y-coordinate, if I put it into the calculator for speed, we've got minus 1/3. So we've got 2 lots of minus 1/3 cubed plus minus 1/3 squared plus 2 equals, and out comes 55 over 27. So this question uses what we've just been looking at, but also brings into play some of the geometry from previous lessons. So, equation of a tangent. A tangent is a straight line drawn on that curve. Hence we need the y minus y1 equals m lots of x minus x1 at some stage. We're told to work out that tangent when x equals 2. So first of all, I'd start with dy by dx and establish the gradient. So we get 4x minus 5 and nothing on the end. When x equals 2, there's two things we need here. Start off with the gradient. So put 2 into there, I get 8. Take the 5, so the gradient is 3. But also, we weren't given the y-coordinate, so I need to put 2 into there. So if I put 2 into there, I get 8. Take 10 plus 1. So we've got minus 2 plus 1, we've got minus 1. Therefore, we can now establish the equation of the line y minus minus 1 is equal to m lots, 3 lots of x minus x1, which is 2. So y plus 1 is equal to 3x, take 6. So y is equal to 3x, take 7. That's the equation of the tangent drawn at x equals 2.